Okay, let's take a limit of a continuous function. This is the most basic and easiest form of limit. And if we understand this, we can kind of understand everything that comes after, right? So the limit basically is literally what is the function value going towards as you approach a certain x value from the left and right. Okay, what does that mean? Basically, let's say if you take this limit, the limit of f of x, which is this graph right here, as x approaches 1. That means we want to scale from the right side of 1 and from the left side of 1, scale from both sides, and go really, really, really close and see where is the graph going as you get really, really, really close to 1. Right? So if we look at this function, we scale it, we go up and up and up, and it's just going to the y level 4. And if we go from the left side, we're coming closer and closer past 0, past 0.5, all the way to 1. It's going towards the y level 4, right? So the limit from the right side is going towards 4, and the limit from the left side is going towards 4. That y value that they're getting really, really, really close to, right, is equal to 4. So when they both meet, if they're both approaching, it's a very common word they use, approaching the same y value, you say the limit equals whatever that y value is. In this case, it's 4, right? Okay, but then you might ask, this is extremely, extremely simple. Why are we saying, the limit as x approaches 1 of f of x equals 4? Why don't we just say f of 1 equals 4? Why don't we just plug it in and just scale the graph? Well, the reason that this is because this is a continuous function, and continuous functions are extremely easy. In continuous functions, you can just plug in the function value. But if we have a discontinuous function, where there's breaks, jumps, holes, asymptotes, right? You get certain complex functions where a graph is going like this, and then all of a sudden it just jumps down here. Or sometimes you have step functions which do like this, and then they jump up, and then they jump up, and they're not all connected the whole way through. Then that's important. So for example, if you take this function, the same exact function, right? Let's redraw it. You take the same exact function, right? But at this one point, x equals 1, there's a hole, right? And let's say it jumps down to like 1. So for every other value, it's going in the same direction as the other function, but just in this one value, it goes to 1, right? So the function value changes. This is a discontinuous function. So the function value changes, but the limit stays the same. Why does the limit stay the same? Because you're still approaching the same value. Once you come from the right side towards this 1, you're still approaching 4. And from the left side, you're still approaching this y value 4. Right? So limits are all about what you're approaching, what you're coming really, 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 really close to, but not exactly touching. Right? So like this, the main question we normally ask about limits is for discontinuous functions. But this is the fundamental principle. If you understand it, you can apply it to any sort of function.